All right, and now it's time for our interview. We've got joining us from Alaska, Marian Call. Marian.
Hi, Fraser.
See, there you are. Now, before we get into the actual interview part with you, because I got a bazillion questions, we're going to give people some context, and that is that we're going to play your cool spacey video. So we're going to go into that, and then so everybody's got context for who we're talking to and why she's awesome, and then we will move into the interview portion of this. So let me just set this up, and here we go. All right.
I was strolling on the moon one day in a merry, merry month of December. May, when much to my surprise, a pair of bunny eyes. Boy, is this a neat way to travel? Isn't it great? I like to skip along.
You're like harmonizing with yourself on the video.
Oh, really?
Good morning, moon, love, how you doing? I've got a
I think I've probably
business
performed that
with
song
you
almost
today.
1,000 times now.
Good evening, sun. I'll see you soon.
No, if you're gonna write a song, you have to write it like do 1,000 times. You better be willing to stomach it. Like, you better be careful what you write.
Who's to say we're going nowhere if we like spinning around and round?
This is probably about when strings come in.
Good morning, stars, love how you are. Nice, we finally see eye to eye. Good day, spec like me, fast and free.
That is
That's
so
how
funny.
we fly. Who's
Oh my
to
God, I'm a
say
baby.
We're upside down, and who's to say we're falling if we miss the ground?
Oh, this was 2012. Sorry. That was so much.
The people are noting that they can all hear us, by the way.
They can?
Yeah. I should have mentioned that.
Good morning, me, love, where you be? Keep your eyes open wide. Babe, we're gonna be alright. Good morning, moon, love, how you doing? I've got business with you today.
And now, let's see, we can get us back. Oh, now Paul's taken over the guest camera.
Sorry.
All right, Marian or Paul, whoever wants to talk.
I'll talk about my amazing music video that you just watched.
Tell us, how did you do it?
How did you
The
do it?
transformation was
Marian.
remarkable.
You know,
Oh man,
special
Hair and
effects
makeup,
nowadays.
amazing.
Yeah,
Yeah.
a lot of hair.
how did you shoot in the cupola on the International Space Station?
I happen to be in the Netherlands, and the cupola is in their module of the space station, and there happens to be an exact scale model of it at SpaceX in just outside of Amsterdam. And so I went with we got special permission and did a collaborative project with them. I got to perform some concerts for some of the folks at ASA, which was really cool. And then we got to film, and they lent me a jumpsuit and everything. It was really cool.
And they just let you use their
Oh,
facility?
it was a long, complicated process. There was paperwork, but it was really cool to be able to actually be in the the space was right. It was the right size. It was the right shape. The windows were really cool. And the whole space center was really neat too. There were, European astronauts visit on the regular, and they were like, there was a lot of fun stuff for kids. It was a really cool center, but yeah, they were very, very kind to let us film during some of their closed hours.
So who are you and what do you do?
Well, that video gives you a pretty good idea. I'm a singer-songwriter. I just work for myself. I write my own stuff, and I'm a one-woman operation with lots of help from really cool fans. And I don't write about the usual stuff like love and romance, because I don't know very much about that, frankly. So I write about science a lot, and space, and fiction, and avocados, and whatever comes to mind. And I lately have done a whole bunch of songs about space. Actually, this one was probably the best known, but I wrote a song for the Eclipse getaway, and I wrote just finished one. My latest song is about Pluto and Pluto's 5 satellites and the other Kuiper Belt objects. And right now I'm working on one with Phil Plait about gravitational waves, and having a good time.
That's great. Well, I know that I think we first met back at like the Parsec Awards. There was a Parsec Awards. You were the musical entertainment at DragonCon. I feel like it was around that time, 2013, 2014. And I know Phil was a big fan of your work. But you've made a great niche of doing fairly is there a name for the kind of music? Nerd folk? Did I just
think
make
it's
it up?
I think it's more the subject. I think that the topic of the song doesn't have to do with the genre, because you could write any kind of song about, in any genre of song, you could write on a certain subject. So it's more that I have a subject I like to write about, and that's science. It's a little bit in the Randall Munroe vein, where I'm interested in science, but I'm also interested in how people relate to science, and how sometimes scientific concepts rhyme with human flaws and features. So yeah.
But anytime you move into the realm of science, you need to also maintain a certain level of accuracy. So have you found that part, the fact checking and stuff, to be a sort of an additional tweak to what you do?
A little bit. It's been a lot of fun. I'm lucky to have attracted as fans a number of people who are also into science, both professionally and just lovers of science. And so it's very easy for me to ask, for example, hey, who knows something about paleontology? Let's discuss, and get a bunch of people who are really passionate about a subject to give me so much information. It's really fun. Well, and going to the Eclipse getaway, for example, was really neat. And I learned a whole lot more about solar eclipses than I ever thought I would. And it was a cool excuse to hang out with a lot of people who are willing to sit around and talk shop. And in the meantime, even though we're talking about scientific principles, I'm thinking, this is pretty amazing. This is a really nice metaphor for XYZ. So
I think of you as one of the people who has really done a great job of being, not only the musician, but also sort of running your own career. And you do this from Alaska. How has that been working out for you? It's tough, right?
I would say that it is tough, but I think that any arts career has always been tough. Like, there was not really a time when it was easy to make a living as an artist. So instead, I'll just say I'm an artist, and that's tough, no matter what level you're working at. But it's definitely worth it.
Yeah.
It's definitely worth it. And there's some great perks to being an artist now, like the internet, that mean I can work out of Alaska. And I love being involved in the actual local music scene here. It's really cool. I need a haircut also, sorry. Hey. But I find it's really, as long as I have the internet, I can connect to people, and there's people interested in what I'm doing everywhere. So we get to be online together, and it's kind of a big party whenever we get together. I do a lot of streaming concerts lately. I'll be doing more this year, where I'll just, throw on something like this, play some songs, play some requests, interact with people in the chat. It's really fun.
Are you doing that like on Twitch?
I've been doing it on Concert Window. I'm investigating Twitch, but I'm not sure. We'll see.
I've seen a
That
lot
might
of people
happen someday.
really crushing it on Twitch, doing almost that exact thing, setting up and then playing a bunch of the songs the fans want to hear, being able to answer questions and things like that. So definitely.
Yeah, I might look into it. So yeah,
Yeah.
I think they have improvements over what I've been doing lately, but it's also tough to get access to some of the nicer features. So
Like monetization and things like that. Yeah.
yeah, kind of important.
Let's talk about how you find your topics. Where do you get your inspiration from?
I have no shortage of like curiosity about new ideas to write about. I have notebooks and notebooks full. I've got a notebook right here with like multiple pages of like song ideas, and and some of them are little and silly, and some of them are big and huge, and I want to write a musical about. But yeah, there's never a shortage of stuff to be curious about in between like history, science, philosophy, and just like people I know and their relationships and their struggles. Yeah, I am really interested in our solar system in particular right now, though. Since I did the Eclipse song and the Pluto song, I'm like, maybe I should actually round this out a little more and maybe I should Gustav Holst it up a little bit and work on, maybe I should start on some stuff for
Or
Saturn and Jupiter and the moons, and yeah,
right,
might be fun.
right.
I'd have to learn a lot more though.
Well, like
Their
They
solar
Might Be
system.
Giants did a great science album for kids.
They were one of my big influences growing up, actually. I listened to so much They Might Be Giants from probably 1989 on. They were like my main listening diet through the end of college.
So how many albums have you got now? Is there even such a thing as albums anymore?
10
10.
albums. Yes, there is. Yes, I have 10. I'm very proud of that.
I thought iTunes doesn't even let you load albums anymore. Didn't they shut that down or something? Maybe I'm a
I
crazy
don't worry
person.
about what iTunes does.
Yeah.
Their last year. It's all Spotify now. No, I put my albums up on Bandcamp, which is a place where musicians have a lot of control over how they can present what they do. And I adore Bandcamp, and I recommend them if you haven't ever streamed or bought music there. I still make albums. I still make works that are meant to be experienced all together. My most recent one is called Standing Stones, and it's more about history, I would say, and the internet and humanity. So it's about human tendencies. And that one is a song cycle that goes sort of from morning till night, or from birth till death, and right through midlife crisis. And it's really not complete. None of the songs is complete without the others. And I have had really great feedback on it. So people are still listening to albums, and that makes me happy because I can still make them. So if I do make a solar system album, then it can be, I'm sure a few people will still care to hear it all at once.
Have you had to abandon a song because you couldn't get the science down?
Well, you never know if a song is abandoned, because you might start it and then finish it 2 years later. So I'm not really sure. But the science is never usually the stumbling block. More often, it's just simply time to sit and write. And time is a scientific principle. So, I mean, maybe that is. I'm not sure.
All right. Well, you're going to stick around with us for the rest of the show, especially because we're going to be talking right away about. Actually, now that I think about it, you're the interview, so you're showing up later on in the show, so I will have to explain this. Never mind. Don't worry about it.
Haha.
Haha. My fault.
Sorry, Chad.
Where can people find out more?
Where can people find out more? I tweet a lot, so that's a good place to find out more. I'm at Marian Call, just my name, on Twitter, and I'm pretty active there. I have a Patreon going on right now. That's how I managed to stay in Alaska. And the Patreon is at patreon.com/Marian Call. That's where I wrote my latest music too, the Pluto and Charon song, and I also added one about Valentine's Day. I just covered some No Doubt, wrote a song about like Deadwood, sort of like Old West outlaws, things like that, just sort of interesting, weird subjects. So if you enjoy that, you might enjoy my Patreon. And last, I'm all over YouTube and the rest of the music world. So just look me up in Spotify, look me up on YouTube. You'll find lots of stuff.
Fantastic. Well, thank you for joining us, Marian, and good luck with all of your. I can't wait to hear your solar system musical. Is that all right if I just turn it into a musical?
Oh, you're welcome to.
All
Please
right.
do.
Yeah,
I
all right.
especially with some Henson style like Muppet action. That would be terrific.
Sounds good.
If there's ever a stage version, I'm totally there.
Yeah,
Awesome.
exactly.
Awesome.
You'll be the
Yes.
next Hamilton. All right. Thanks, Marian.
No expectations.
How does a gaseous molten corpse?
That's
you for
scarily
that.
impressive right there.
Well, haven't you always wanted to insert gaseous into a rap song? I have.
Yes, I really have. How did you know?
We're on the same wavelength, Kimberly. I can tell.
All right. So now we're going to start back at the beginning. Everything's all mixed up. It's all backwards, but we'll figure it out. Chad will just do his magic. And then
Good luck, Chad.
Good luck. Yeah, we really messed up Astronomy cast, too, so he's got his work cut out for him. All right, here we go.
Sorry.
Oh, no, it's not your fault. It's all my fault.
That was a collective apology I was making.
Oh, thank you. Welcome to the Weekly Space Hangout for Wednesday, March 21st, 2018. It says March 21st. Anyway, I'm Fraser Kane, publisher of Universe Today. This week we're going to be talking about RTGs are back on. Europe's Next Planet Hunter, New Horizons' new target, has a new name, and a prehistoric nearby star, and maybe some other things if we have time. Maybe one other thing.
Maybe we'll talk about Stephen Hawking's last paper.
That was the hope. That was the hope.
You sound thrilled.
Oh, it's so exciting. Who doesn't like conformal field theory?
Well, you heard him. We've got Dr. Paul Matsutter here.
I introduced myself.
We've also got, actually, well, you know what? I'm going to give you his official title just so I don't get it wrong. Dr. Paul Matsutter. He's the astrophysicist at Ohio State and host of Ask a Spaceman. We've also got Dr. Morgan Renberg. Dr. Renberg.
Hey, Fraser.
Morgan is the director of scientific presentation at the Fort Worth Museum of Science and History. And we've also got Dr. Kimberly Cartier, the Earth
Hey,
and Space
Fraser.
Science reporter for EOS Magazine.
That's right. Hey, Fraser. And if you couldn't tell, I was raising my hand when I said I don't like conformal whatever theory that Paul's going to talk about. I was raising my hand.
To not hear
Way to
it?
be non-conformist.
Yeah. No, the
I'm sure
The
it was
fans
a fascinating
demand
paper
to know
about something.
about Hawking's
stuff.
final
Happy
theory.
podcast day, though. I hadn't said that yet. Happy podcast day. I can't go by without my traditional greeting.
And joining us for the entire show is our extra special guest, Marian Call. Marian,
Hello.
joining us from Juneau, Alaska. No, Kimberly's just going to hog the screen. Oh, well.
Let me be louder. Hello, everyone. I'm in Alaska. Does this look like Alaska? I hope it does.
Looks like a
That's
recording
exactly what I
studio.
imagine Alaska to look like.
All right, so before we get on with the show, I just want to remind everyone a big thank you to the Weekly Space Hangout crew. This is, of course, the fans, the executive producers of our show. They're the ones who decide who the guests are. They're the ones who recommend a bunch of the stories, and we are so glad to be partnered up with them. So if you want to join this community, join the chat down at the bottom. Go to wshcrew.space. All right. Space TV says, please talk about Hawking first. Paul, how about 60 seconds, and then we'll move on to what you really want to talk about.
Stephen Hawking's, and the headlines are ridiculous here. Like,
I know.
he's
Well,
submitted-
that's the part. That's if we can do one thing, can we give people some context about what he actually said?
Yeah, so the headlines are going on about how it's like his final paper, his final theory submitted 2 weeks before he died, concerns the end of the universe and how we might live in a multiverse and how it might be detectable. So all of that is wrong. Like
Headlines are wrong?
every single statement. Yeah, but usually headlines are just wrong in a small way, like one little thing. Now it's like every single word is incorrect.
Right.
So
This
what did he
week-
actually say?
So he wrote this paper last July, and it's just, I don't know. It's actually about the early universe, not the end of the universe. It is about it's about something we call eternal inflation, where inflation was this event in the earliest moments of the universe where it rapidly expanded. We don't know a lot of the details of that event. One particularly interesting theory within the inflation family is something called eternal inflation, where like blowing bubbles into foam, a lot of little universes percolate out of the quantum foam in those earliest moments. So you get lots of universes all populating this big giant multiverse kind of structure. But there are some issues with that about how you go from little universes percolating out of the quantum to something that actually looks like a growing universe that's stable and behaves well that we see today. Making that transition is very difficult and not something we've been able to pin down mathematically. And this paper was just kind of exploring, playing around with some toy models associated with that to see if there is a way to exit the eternal inflation scenario to lead to a universe that we might recognize today.
So he was proposing a way that eternal inflation could end and reintegrate with the rest of the inflating universe.
Yeah, eternal inflation would end, and then one of these bubbles would eventually evolve over the course of the next microsecond into the universe that we know and love. That is a tricky thing to do in the mathematics, and he didn't solve that problem. He was playing around with a toy model that's related to that problem to just kind of probe at it mathematically to see if there are any avenues for moving forward.
All right. There. You did your...
That sounds nothing like the headline.
No, it sure
Imagine
doesn't.
that.
Well, but you did your part for society. Paul, you did your bit. We appreciate that. You're a good soldier. Now, why don't you talk about the new name for New Horizons' next target?
Yeah, so the New Horizons team has proposed a name for their next target, and the name came about through part from internal deliberations and a public competition. The old name, which nobody likes, is 2014 MU69, and the new name that they're proposing is Ultima Thule, or Thule, which means beyond the borders of the known world, which they thought was sufficiently poetic and cool sounding. It won't be its official name until New Horizons actually does the flyby and is able to characterize it, because for a long time we thought it was just a single object, although more recent observations suggest it might be really, really elongated in a weird way. It might actually be two objects in a small binary orbit. And until we know that for sure, we can't pin a name on it.
And also, it's not their ability to name objects.
Well, I think it should be. So technically, all names have to be approved by the International Astronomical Union. Who gave them that authority? The International Astronomical Union. So
They voted on it. They voted that they gave themselves the right
to name things.
name
and
things,
technically, if it's not named by them, then it's unofficial. But if the New Horizons team wants to call this thing Ultima Thule, and then the IAU says, no, we're going to call it Fraser, then everyone's in their papers is just going to call it Ultima Thule.
I think we saw that same sort of phenomenon with the exoplanets, where everyone was calling exoplanets one thing and writing papers about it, and it was all accepted for decades. And then the IAU came along and said, no, we're going to call it Excalibur or something. I don't even remember what they're called
Excelsior.
now. Sure. And no one uses those. But I think with what they're hoping to happen is the same thing that happened with the features on Pluto and Karen as well, where there was just so much community momentum with the unofficial names for the features of like Sputnik Planum and all the different craters and such, that the IAU pretty much had no choice but to say okay.
They were in a long battle with the IAU over the various provisional names that they had a much sort of more public battle than I think most mission teams are. And so it's not surprising that they're trying to get out in front of this one to sort of stake their claim.
And to say like this is our nickname, yeah, I think you're exactly right. When you look at what happened with the team previously, they're renowned thing namers and have
Thing
gotten
namers?
thing namers. Yeah,
Yeah.
We need a name for thing namers.
yeah. I just gave them the name.
I
So-
like that they've decided that now it's a combination of sort of internal debate as well as public submission, because I'm just waiting for a Planet McPlanet face scenario to come up. And you know it's
Yeah,
going
I
to.
think they wanted to avoid exactly that scenario.
Right.
But I really would love a Planet McPlanet face, and
You know,
everyone else would too.
The
I'm sure that
2020
during
rover's
the-
going to need a name.
Yeah. Well, that's true. But I'm sure during the public submission, there were plenty of nominations
Yeah.
for Planet McPlanet Face or little oddball guy out there or whatever. I'm sure there was
Or
some sort of
Steve.
they got like hundreds of nominations for names and then only let people vote on like 37 or so.
The ones they like.
But I
best.
think
The
it's
ones they like the most.
it's a great way to go about it, right? You give it your nickname, and then once you've given it your nickname, then it gets used by everybody, and then someone is gonna, and then the IAU is gonna be going against the stream. Although they're gonna probably be pretty mad that
I don't care.
the
Call me
New
old
Horizons
fashioned,
team
but
went
I
this
think
path.
discoverers get naming rights.
I
But
mean, I
they
think
didn't
51 peg is
discover
always
it.
51 peg no matter what the IAU calls it.
right.
Yeah,
The New Horizons team didn't discover it,
fair enough.
right?
It's true.
But I'm sure they're in cahoots with the people who did.
They didn't map it. They're going to map it.
Yeah. So they could
So-
name regions on it. Anyway,
Did anyone here actually vote in the public competition?
no.
I didn't even know there was a competition.
Oh, am I the only one who voted?
You voted?
I
think
am.
you are.
I
What did you
voted.
vote
I did
for?
vote, not this one. I did not vote for this name.
Oh, okay.
I think I voted for one that was like way down in the rankings. I don't remember which one it was.
Kimberly.
What do you think
There
makes a good exoplanet name? Like what do you like?
Well, something that is easy to remember and easy to use and not too different than what we're already doing. Something that's not too different, not too difficult to like shift into. Which actually, I think 51 peg became Decidium, which
No one.
They're trying to make them all sci-fi sounding.
yeah,
Hmm.
That sounds like something that would power the Enterprise or something. Oh, we're running out of Decidium, Captain.
All right, well, let's move on. Morgan, you're on my screen right now, so why don't you tell us the good news?
Yeah, well, before I tell you the good news, let me tell you the bad news. And that's that
I
outer
believe I was
planets-
pretty clear that I would like to hear the good news.
think
And
I'm
no
leading
bad
with the
news.
bad news.
Charge.
Nothing you can do about it. Call the IAU. Outer planet
picking up the-
science is in trouble. With the end of New Horizons in sight, with Cassini over, there's currently one mission in the outer solar system, and that is the Juneau mission at Jupiter. And on the roadmap are two more missions to Jupiter, NASA's Europa Clipper and the ESA mission JUICE. And that's it. And those will launch sometime in the next decade. And beyond that, we really have nothing. And so we're looking at a long gap between now, basically, and an inevitable mission to Uranus or Neptune, in which there's the possibility that the outer planets community worldwide will lose a lot of its scientists to other fields of science, to other parts of astronomy, or just out into industry. And that's a problem, obviously, for those of us who would like to see, ultimately, exploration to the far reaches of the solar system. And part of the reason there are so few missions is because they're so challenging to do. You need a lot of redundancy. You need a power source that isn't solar panels because the sun is just too weak. Juneau is the first mission to ever use solar panels at Jupiter. Neither the Europa Clipper or the JUICE mission will be using solar panels. And so it's almost impossible to do a real mission without an energy source that isn't solar panels. And what we've used in the past are what's called a radioisotopic thermoelectric generator, which is basically a hunk of plutonium that gives off heat. And then there's a bunch of machinery around it that converts that heat into electricity. And the Voyagers have successfully used these to fly for 40 years. And New Horizons carries one, Cassini carries one, the Pioneer missions carried them. And that's basically how you have to do it. The problem we have right now is that the cheapest, most accessible, and most common missions that NASA offers, the Discovery class of missions, which have budgets up to about $500 million, didn't allow the use of RTGs. And so that basically meant that most of the missions that are launching every few years, missions that you can think of, like Kepler, for example, or Messenger, or the Mars Reconnaissance Orbiter, or the Lunar Reconnaissance Orbiter, or LADEE, all of these missions that we're thinking about, those are all discovery missions that can keep this pace going and can sustain a community. And they couldn't go to the outer solar system because it was impossible to do them with solar panels. With just solar panels. And the good news here is that NASA has decided that they're going to allow the use of RTGs on future Discovery missions. And they can do that because we're finally producing enough plutonium to sort of sustain ourselves. For a long time, we weren't producing any plutonium for space travel use. And we were basically just drawing down stores that the US and the Russians had on hand. But a few years ago at Oak Ridge National Lab in Tennessee, they started up the production of plutonium once again, and that's feeding us a supply that'll be enough to maintain these small RTGs that these cheap Discovery missions will need. And that doesn't guarantee that you can send a mission to the outer solar system, but it at least removes the largest barrier to doing so. And that's great news for exploration.
There's going to be one in the Mars 2020 rover, though, right?
Yes, most of the plutonium we have on hand right now is for Mars 2020.
Are there any plans to, I guess, plans already to integrate this new power source into some missions that are being planned?
I don't think so, because nobody who had proposed a Discovery mission, had this option. And so the design's already progressed to the point where you wouldn't sort of make this sort of change. But it means that for the next cycle of Discovery missions, and those happen sort of roughly every 3 years, there'll be a new opportunity for designs that from scratch allow the use of an RTG. And there's still hurdles. To go to the outer solar system, NASA imposes higher reliability requirements because it takes longer to get there. And you want to make sure that your spacecraft has a reasonable chance to survive the trip. And those higher requirements yield more cost. And that still is tough to fit inside of a Discovery class budget. And they often constrain what launch vehicle can be used. So something like an Atlas V, which may or may not have enough power to put the spacecraft that you want in an outer solar system trajectory. And so there's still hurdles, but the biggest one has definitely been removed, and that's great news.
But if there's this damage to the community because of the lack of missions for so long, how long will it take to ramp back up to our existing capacity or the capacity of 10 or 20 years ago?
Well, the hope, I would think, is that we never get that bad, because maybe we can get a couple of these Discovery missions to explore sort of the Jupiter-Saturn region. You could imagine a Discovery mission that might be able to do in orbit around Titan, or a flyby of the rings of Saturn, something like that, that would allow a core of outer planet scientists to remain, that would then go on to be the principal investigators and the instrument scientists of a future flagship mission.
I mean, I can think
combine
of,
that.
Oh, I was going to say, I can think of the recent, the latest Discovery mission plan, the ones that were, they're considering, they're sort of coming down to those two final missions, right? There's the Cometary mission, the Caesar mission, which is going to be an analog of OSIRIS-REx. It's going to have solar panels. And then there's this Mars Dragonfly concept, and that would have an RTG, and it would fly around the atmosphere of Titan. And so they wouldn't be able to move, like that decision would be made for them. They'd have to go with Caesar if the RTGs
I think that
weren't cleared up.
mission, I think that mission is a New Frontiers.
Oh, it's a New Frontiers
class,
mission.
which
So
is the middle class. And so
Right.
you can see just enabling it. There's more money in the budget, but just adding that RTG enables this fascinating mission concept that would be impossible to do without that capability. And so the hope is that we'll be able to get a stream of these smaller missions, whether they're discovery missions or New Frontiers missions, that can tide us over until the next big mission to the outer solar system that will bring sort of that magic that Cassini or Galileo brought to the outer solar system, or the Voyagers, if you went back far enough.
Yeah, I thought
Yeah, I
you
mean,
already gave
even-
us that bad news at the beginning, though, about that.
Yeah. But I mean, even if you got a small Discovery class mission around Uranus or Neptune, you would get so much more science and so much more information than we currently have on those two planets. Because when we visited them exactly once, and that was 40 years, almost 40 years ago now. And there's so much that we don't know. And like you said, if we could just get something, it would ramp up the excitement and the energy towards the outer solar system, like Cassini did, like Juneau's doing. You just need to get that excitement there.
Yeah, it's going to be hard. If NASA really wants to incentivize missions to the outer solar system, they're probably going to have to make some more concessions in the Discovery program to do it. I spent some time once working on a project to try to design a Discovery mission to do orbit around Europa, the closest outer solar system target, and it was nigh impossible, even assuming you could use an RTG, even assuming they threw in a launch vehicle, because the redundancy requirements are so steep, because you have to carry so much fuel to go into orbit around an object in the outer solar system. So there's going to have to be a balance between what's possible in a Discovery class budget and what's necessary to do an outer solar system mission. And hopefully we can find a way to split the difference in that enables the amazing exploration that we've been having around Mars, around the moon, now to the asteroid belt. We've reaped incredible gains in the last decade with the Discovery program in the inner solar system. And it'd be great to see some of those benefits show us new things in the outer solar system too.
If you could choose, Marian, where would you like a mission sent? If you could have
More Saturn.
More. Yeah.
And Neptune. I really love Neptune also. But I was just reading about, I don't know how useful this is for a project like that, but that 3D printing is starting to reach a point of precision and reliability that they're looking at potentially being able to make the next few spacecraft for missions like these with potentially hundreds fewer parts, which would mean a lot less weight.
I put that into the list, actually, which is this company called Relativity Space.
We'll see how they actually do, but that is an interesting prospect that hopefully, there's been so much progression as far as cameras and software, and but for the hardware to catch up really is what would make it so much easier to deal with the redundancy requirements of missions like that.
NASA, from time to time, has invested in trying to sort of jumpstart a modular spacecraft platform, and LADEE, that crashed into the moon a few years ago, was a test bed for this idea. Is that a lot of the expense that goes into designing a spacecraft is basically each one is built bespoke. And if you go back to the 60s, when we were just flinging spacecraft everywhere with the Mariner program, the Pioneer program, a lot were succeeding, a lot were failing, but they were all built on common designs. And that allowed us to build more spacecraft more rapidly and go more places. And if we could combine this idea of 3D printing with designs that we know work because we've used them on previous missions, and then throw in a reusable rocket like the Falcon 9, that seems like the recipe that we need to get this low-cost exploration to go beyond Mars orbit. And finally, all the pieces are coming together for that.
I also wonder, there's a little bit of a private-public question there as far as the conflict between private companies wanting to keep every aspect of every piece of hardware proprietary as much as possible, and software and everything, versus the public interest in being able to do this inexpensively, and different companies and public-private partnerships being able to send up things more efficiently would mean that there might need to be like an agreed upon adapter, agreed upon, sizing for parts. And that is weirdly, it conflicts with the capitalist demands of a private space program, but it also would mean so much more exploration if there could be agreement on that. The way that, audio cables are still one of the last kinds of universally agreed upon adapters around the world, and God forbid that ever go away. But
check your iPhone 10.
I got bad news
Oh
for
no,
you.
I'm never doing it. Never doing it. I'm never going. But like the fact that an XLR cable that you're using for your microphone, for example, is universal the world round is one of the parts of kind of the legacy of tech design that is in danger of vanishing. But if we can restore it to some degree, or at least have agreement on, universal adapters for things as specific as space flight and as expensive as space flight, like not just, not just modules that can clip together with agreed upon specs, but even down to the wiring and the electronics, like that's going to be a conflict anyway.
Yeah,
I think.
I think it
private,
would be
proprietary everything versus like public. Hey, anyone can make a piece and put it on another piece and make this happen, make it fit.
It would be wonderful if we could get, cookie cutter probes sent to many different destinations for a fraction of the price. You wouldn't necessarily get the same depth of science as you do with a bespoke mission, but it sure would be wonderful to have that kind of, that many eyes on the solar system. We talked about this a few months back, about this idea of sending a bunch of spacecraft to go and examine hundreds of asteroids, and Morgan thought that sounded like a great idea to get that much science for that
at least worth
price.
exploring.
Yeah, worth exploring. All right, well, let's move on. Kimberly, let's talk about Europe's next planet hunter.
Yes, more planet hunters, finding more exoplanets. The European Space Agency has selected their fourth and the next medium-class science mission that they're going to build. It is an exoplanet mission called the Atmospheric Remote Sensing Infrared Exoplanet Large Survey Mission, or ARIEL. Apparently, they're going to skip some letters in that acronym to spell out ARIEL. And it's going to be a space telescope about meter class in size, and its job is going to be to look at the atmospheres of hundreds to thousands of exoplanets, and pretty much just the atmospheres. It's an infrared mission, essentially going to be doing transmission spectroscopy of hot and warm exoplanets, super Earths to hot Jupiters, essentially, trying to figure out what these planets' atmospheres contain, whether it's water or CO2 or methane or some exotic metallic compounds or something, and trying to connect that to the chemistries of the stars themselves to figure out why certain planets form with certain atmospheres given the environments that they're brought up in.
That is awesome. And if it was like 2 months ago, I would be super excited and say, so this is it. This is how we're going to know about life. But now, as you've educated me, I know that biosignatures are hard to find.
Biosignatures are very, very difficult. And given the types of planets that they're going to be looking at, which are the warm to hot or extremely hot planets, searching for life is probably not going to yield any results. They're only going to be looking at a handful of the more warm or moderately cool planets like Earth in the habitable zones. Those atmospheres are they're typically those planets are further away from their stars, and they don't shine nearly as brightly because they're not as hot. And so they're much more difficult to study in detail. But one of the real benefits of a dedicated exoplanet atmosphere mission, which I cannot believe I'm actually saying that. That's so cool. That's what I did.
Yeah, you don't care about aliens. You want to know about these exotic
I don't care about
atmospheres.
exoplanet atmospheres at all. That wasn't even my dissertation. I don't know what you're talking about. One of the real benefits of a dedicated atmospheres mission like this is to start to understand the varieties of types of atmospheres that you can get given a particular kind of star. And I think that's something that we have started to understand even a lot about our own solar system, as Morgan talked about a few weeks ago with some of the results from Juneau, is that Jupiter's atmosphere, which we thought we understood, behaves very, very differently than Earth's does. Even though we're around the same star, we formed out of the same material, behaves quite differently. And so we're starting to get this idea that not all atmospheres work the same, even if they're around the same star. And so we need to start to understand why things work, why atmospheres work the way they do. So we can start to, I guess, get an idea of, what conditions are possible for life. And I think I've talked so much about how you can have a planet in the habitable zone of a star, but that doesn't make it hospitable. And that atmosphere is such a key component of what things might actually be like on the surface of that planet, underneath that atmosphere. So we really need to start getting at what these atmospheres are, what they can do, and why. And that's exactly what Ariel is going to try and figure out.
Yeah, Venus is in the habitable zone of the solar system.
Yeah, Venus is in the habitable zone. Mars was in the habitable zone at one point. Now we are, and who knows what we're doing. And there's Jupiter, which behaves totally different than Saturn does. And then Uranus and Neptune, like I said, we have no idea what's going on there. So, I mean, there's just such variety of atmospheres. And quite honestly, this mission, I think, is going to yield quite a bit of great science, even if we never find, biosignatures in these worlds. Just starting to understand why planetary atmospheres form the way they do, and how they could be related to more of the bulk properties of the solar systems they live in.
Did you say when it's going to launch? Did I space out?
Oh, I didn't. It's they're planning on launching it somewhere around 2028, and they actually haven't designed the full specs of this mission yet. They're now that they've chosen it, out of account of there's a lineup of 3 different missions that they were going to choose from. One of them was a plasma physics mission, and one of them was a high energy astrophysics mission. Now that they've chosen it, they can actually dedicate some time to designing it to do exactly what they want. And so they're hoping to start building around 2020 and then launch 2028. So not
That's
too
so far away.
It's 10 years. It's 10
How
I
does
wanna know
this compare
now.
and contrast to TESS?
So Ariel and TESS are going to be quite different. So TESS is going to be hunting for exoplanets, finding new ones by staring at patches of the sky for anywhere from 28 days to, its full 2-year mission to get all sky coverage. And it's going to be doing essentially a giant transit survey to find these planets. Ariel is going to be more of a point and shoot type of telescope, where you already know what planet you need to look at, because you know that it transits and you know that it has an atmosphere that could be, or you think it has an atmosphere that could be visible, given what you already know about the system. So while TESS is sort of a giant net that's going to try and capture all the planets that it can, Ariel is going to be I know what I'm looking at. Let me get as much information about it as possible.
So how's it going to compare to James Webb?
It's much smaller, I will say. It's a meter class telescope as opposed
It might
to
go up first.
tennis court size. Don't you say that, Paul.
Oh,
Don't crush
Cole.
my
So
dreams.
mean.
Don't crush my dreams.
I think we're having Paul Geithner is going to come back at some point and give us an update. So
No. Ariel is going to be, it's much smaller than Webb. Webb is going to cover a much larger swath of the infrared part of the spectrum than Ariel could ever hope to do, because Ariel is such so much smaller, and it's definitely on a smaller budget and built in a smaller time. But it's going to be tailored to look at the part of the spectrum where exoplanet atmospheres shine the brightest and are likely to have interesting chemical signatures like water and CO2 and methane, and even some of these strange metallic things that we think might cause some interesting physics to happen.
I'm looking forward to just all these weird planets that we're going to hear about. And like this one, it rains molten lead, and on that one, the winds are blowing at 10,000 kilometers per hour, and so on and so forth. So
that's another cool thing, is that mostly they'll be doing sort of like bulk properties of the atmosphere, like what is it made of, what's the temperature like at the top and the middle and the bottom. Some of them they're actually going to be staring at for days at a time to try and get more daily and weekly weather patterns of clouds and see how it changes from day to day. And that'll be quite interesting, because we haven't really had the resources to do that yet.
super exciting. All right, so my story, pretty quick here because we don't have a lot of time left as usual. And this is that let me see if I can find the story here. So astronomers have known for a couple of years that the star had passed fairly close to the solar system. It had come within 0.7 light years, and it's called Shoal Star. It was discovered a couple of years ago that it had made this close encounter to us. But sort of the new research that came out is that astronomers had mapped out 300-ish comets and asteroids, and found that they could detect its influence in the movements of these smaller bodies in the solar system. We're able to tell that it had moved through the solar system and kind of disturbed all of these objects as it had done so. And it had done this about 70,000 years ago. So when it got to its closest point, it would have been slightly visible in the sky. It's a red dwarf with, I think, 9% the mass of the sun. So they're still pretty hard to see. But it's still pretty interesting to see that the gravitational impact of these objects coming through the solar system and can still be detected now. And it sort of gives a lot of hope for the search for Planet 9, which is out there detected only through the gravitational influence of other objects in the Kuiper Belt. So maybe. Are you now skeptical that Planet 9 is out there?
I am. Mike Brown, actually, he had a very interesting comment. He said if someone else had announced this discovery, he would be incredibly skeptical. And so he expects the community to be skeptical. So I'm just doing what Mike Brown wants me to do.
Just keep it calm, keep it down, just chill it out.
Just show me a picture, all right? That's all I need.
Yeah.
So some models of the Oort cloud suggests that the Oort cloud could extend halfway to Proxima Centauri. And, that would be, a light year or something. So it's conceivable that as this star passed by, it stole or is in the process of stealing objects from our Oort cloud. And, we could also have stolen objects from its Oort cloud. And so there's a thought that every time we see a comet coming in, it's a possibility that we'll have a chance to see some extrasolar material that is being exchanged at the edges of our Oort clouds with all of our nearest stellar neighbors. And that's kind of a cool thing.
Now, if I understand it right, the interstellar asteroid Oumuamua was not from this passing star, correct?
Right. And in fact, the thing that's been making the rounds this week is that maybe it came from a binary system.
I did see that, yeah.
Although I don't know what the evidence was.
How would we know that? It just
The
kind of looks binary.
I was
Binary
afraid to
stars are
bring this
more-
up. Hold
Yeah, I
on.
didn't. I noticed that. I didn't know either. My guess is binary star systems are going to be more unstable, especially
Yes.
in early
Yeah.
formation.
They have a higher chance of ejecting objects.
So it's just a statistical argument.
It's a
There's
statistical argument that binary stars are more likely to kick things out,
Yeah.
and binary stars are pretty common. So,
Yeah.
yeah.
All right. Well, now
Good
it's
old
time
stats.
to wrap things up. At some point in there, we played our interview and did our video with Marian, who's been here the whole time. I know this is very complicated for everybody, and I apologize in advance.
And to Chad, sorry again.
Kimberly, tell us something that you worked on this week.
So this week I worked on something pretty cool, or that's not going to publish until probably next week. But if you've heard of an aurora named Steve, then check out something that I'll be publishing next week.
Right on.
Yeah.
Morgan.
I just had my latest video with SciShow drop yesterday. It's all about pulsed plasma thrusters, which is a much less cooler way of saying spacecraft thrusters that eat Teflon. So next time you're frying something in your frying pan, you think of a thruster.
I'm gonna have to watch the video.
It's pretty cool.
Right on. Paul, what's something you worked on?
Hey, actually, I want to talk about astrotours again, but this time it's not mine and it's not yours. It's Ethan Siegel's trip to Iceland next January. If you didn't go to Iceland this year and you really, really like bald people, then this trip is for you because we found a substitute bald guy. So you need to go. Ethan's amazing. It starts with a bang. Wonderful, wonderful science communicator. Great guy to hang out with. go to astrotours.co or astro.tours. Both go to the same place and look for the Iceland 2019 trip and sign up today.
Right on. Okay, and what did I do? Oh, we just dropped a new episode for the Guide to Space today, all about how photographs from space work and photographs from spacecraft. So check that out. And Marian, we're going to give you the last word, one last chance to tell people where to find out more.
Where to find out more? I would just go to YouTube and look me up. You'll probably find first our sweeted David Bowie video, the Randall Monroe David Bowie crossover video. Anyway, if you find that first, you'll find our original work later.
But Marian Call. Awesome. Thanks, everybody. Thank you so much for joining us this week, Marian. Really appreciate it. Thanks to the Weekly Space Hangout crew. Reminder, go to wshcrew.space and you can join this community. Thanks to Paul. Thanks to Kimberly. Now it's time for everybody to say goodbye.
And thanks to Morgan.
And thanks to Morgan.
Thank you, Kimberly.
Morgan.
To Morgan.
What do you think with his little earpiece now and not his great big mission control
I
headset?
broke
I
my
like it.
headphones, and Fraser says it's so much better now.
Yeah, it's nice to see.
Show off your skull, man.
Yeah.
I like the security of knowing my brain was clamped in.
All right. Thanks, everybody. We'll see you next week.
See you guys.